Good day, grade 10. Once again, I'm your Ate Monina, your student teacher for this lesson. Our topic for today is Boyle's Law. In your previous year, you learned that matter, which is liquid, solid, and gas, was made of molecules. But for this lesson, we're going to focus on gas. Gas is defined as a state of matter consisting of particles that have neither a definite volume nor definite shape. As we all know, gas is everywhere around us. One good example of this are the atmosphere. It is a combination of gases like oxygen, nitrogen, and other gases that are very essential to life. Here are some general properties of gases. 1. Gases are compressible. Gases are compressible because most of the volume of a gas is composed of a large amount of empty space between the gas particles. Compressibility is the property of being reduced to a smaller space by pressure. 2. Gases fill any container that they occupy, but if the container is not sealed, the gas will escape because the intermolecular attraction force is very less as compared to solid and liquid. 3. Different gases mix completely. Gases will mix completely and evenly when confined to the same volume. And 4. Gases expand in the presence of heat. When a substance is heated, its molecules move faster. 5. Gases does not settle in their container. As you can see in the example, the gas particles are in a constant random motion and constantly collide with each other and with the walls of the container. And this movement explains the behavior of gas, and there are 3 ways to increase the pressure of gas. 1. Forcing more gas into the container, so thereby increasing the number of collisions per unit of time. Second, decreasing the volume of gas, thus shortening the average distance between the molecules and eventually increasing the number of collisions per unit of time. And last, heating the gas in a closed container, it increases the speed of the molecules and the number of collisions per unit of time. The speed of the moving molecules is the result of the kinetic energy increasing by heating, and the decreasing is by cooling it. Before we continue discussing the gas law, here are the scientific postulates of kinetic molecular theory. 1. A gas consists of very small particles, each of which has a mass. 2. The distance separating gas particles are relatively large. 3. The gas particles are in constant, rapid, and random motion. 4. Collision of gas particles with each other with the walls of the container are perfectly elastic. And 5. The average kinetic energy of gas particles depends on the temperature of the gas. The gases which have higher kinetic energy has a higher temperature and a lower kinetic energy at a lower temperature. 6. Gas particles exert no force on one another. In other words, the attractive forces between a gas particle are so weak that the model assumes them to be zero. Boyle's law. So Boyle's law. The law was named after the chemist and the physicist Robert Boyle, also an Irish scientist who discovered the inverse relationship between volume and pressure. So this law was stated that the volume occupied by a gas is inversely proportional to the pressure if the temperature remains constant. So it means that in a constant temperature, if there's an increase in pressure, volume will decrease, and if there is an increase in volume, pressure will also decrease. So Boyle's law is expressed using this equation. P1 times V1 is equals to P2 times V2, where P is initial pressure, V is the initial volume, P is the final resulting pressure, and V2 is the final resulting volume. In this table, it's shown the unit used for measuring pressure. So we must be familiar with the atmosphere, the milliliter of mercury, the torricelli. So let's try to solve the problem using Boyle's law equation. Here are the sample problem. What volume will 500 ml of gas initially at 25 degrees Celsius and 750 milliliter of mercury occupy with condition changes to 650 milliliter mercury at the same temperature? So we're going to list down all the given. Looking for final volume, going to derive the formula. Multiply both sides, and the result, the final volume is equals to initial pressure times initial volume divided by the final pressure. Going to substitute the given values for initial and the final pressure, and the final volume is equals to 577 ml. There are several applications of Boyle's law that greatly help us, especially in the field of medicine. So one of the direct applications of Boyle's law is a chest respirator. It is a machine used in the treatment of patients with the respiratory difficulties. So another use of Boyle's law is the use of a sphygmomanometer. It is a device used to measure blood pressure. When the rubber bulb is squeezed, the volume of air in that bulb is decreased and its pressure is increased. So this increase of pressure is transmitted to the cuff. There's a lot of uses of Boyle's law in our daily lives. And that's the end of our lesson for today. Thank you for listening and hope you learned something.